everyone. This video will show how to change the general form of a parabola to its equivalent vertex or graphing form. So pretty much we are given the general form and we want it to look like this. And this is an example of a vertex form or graphing form. We also have this another case right here, and we wanted it to look like this. And we also have to sketch the graph after that. Before we dive into some examples, let's have a review on the basics of parabola. We remember that there are 4 cases of a parabola with vertex at hk. But before we dive into these 4 cases, let's have the parts of every parabola. The first part that we need to remember is the vertex. So this is located right here. So this is our vertex, and this is actually represented at hk, coordinate hk. Another part that we have is the focus. So this is our focus right here. Now we remember that the location of the focus from the vertex determines where the parabola opens. If the focus is located to the right of the vertex, that means that the parabola will open to the right. On the other hand, if the focus is to the left of the vertex, then the parabola opens to the left. We also remember that the distance from the focus to the vertex is represented as P. And this is also P right here. Another part is the ends of the latus rectum. So these 2 points that we have here are the 2 ends of the latus rectum. We need these 2 ends in order that we can graph the parabola from the vertex. Okay, now we remember that the distance from the focus to one end of the latus rectum is 2p. So I'm going to go ahead and write that up here. We also remember that this value of p here, which is from the vertex to the focus, this value right here will be negative. The reason for that is because it's going to the left. While on the other one right here, the value of the p is positive because it's going to the right. Now, another part that we need to remember is the directrix. So this is the directrix right here, represented in a broken line. Now, we also remember that the distance of the directrix from the vertex is also P. So I can go ahead and label that up here. This tells us that the vertex is actually in the middle between the point where the directrix passed through and the focus. So the vertex is in the middle of these 2 points. Another part of the parabola is the line of symmetry. The line of symmetry will always pass through the focus and the vertex. So this is our line of symmetry. On the right, you will see the first case. I labeled it as case 1, and that is when the parabola opens right. And well, case 2 is whenever the parabola opens to the left. For these 2 cases, the equation that we are going to use every time will be quantity y minus k squared equals 4p quantity x minus h. So this is the equation that would work for these 2 cases. We remember that the sign of the p matters between these 2 graphs. Whenever the p is positive, it opens to the right. Well, if the p is negative, it will open to the left. So they're pretty much the same thing, but the p matters because it determines where the parabola opens. Now let's have the third and the fourth case. The parts of the third and the fourth case are pretty much the same thing. We have the vertex. We also have the focus. Now, looking at this for case 3, since we again remember that a parabola opens towards where the focus is from the vertex. Since from here, our focus is located above the vertex, then the parabola opens up. In this case right here, since our focus is below the vertex, then that means that the parabola will open down. Again, we remember that the distance from the vertex to the focus is represented as P. And so from here, we can go ahead and say that the P value here is positive because it's above the vertex, while the P here is negative because it's below the vertex. Now, the other parts would be the ends of the latus rectum. So we're going to need these 2 points together with the vertex so that we can sketch the parabola. Now, we remember that the distance from the focus to the end of the latus rectum is 2p, and this is also 2p. The same thing for this one right here. This is 2p and 2p. Another part is the directrix. We remember that the directrix is always located opposite to the focus from the vertex. So it's going to be opposite to the focus from the vertex. And then we also have another part here is the line of symmetry. So the line of symmetry is a line that passes through the focus and the vertex. For cases numbers 3 and 4, the general equation of the parabola would be quantity x minus h squared equals 4p y minus k. This is the formula that would work for these 2 cases. Case number 3, when the parabola opens up, and case number 4, when the parabola opens down. We remember that if the P is positive, then it opens up. And when the P is negative, then the parabola opens down. Okay, so let's go over this example. Write the vertex form and sketch the graph of the given parabola that we have right here. Before we jump into the steps on how to change this into its equivalent vertex form, I'm just going to go ahead and rewrite this equation. Okay, the first step that we have to do is to group together all the x's, and we will add 4y to both sides and subtract 8 to both sides. I'm just going to go ahead and do that here. So what are we going to do now is we're going to change this side of the equation to a perfect square trinomial by completing the squares. We can do that by adding a blank to both sides. So I'm just going to go ahead and write it down here. Okay, what we fill into the blank is this. First, we're going to take this middle term here. We always have to divide it by 2. So that's going to be 4 divided by 2 is 2. And then after that, we are going to square it. So that would be 2 squared. And that gives us 4. And this is the number that we put into the blank. So I'm putting 4 on this left side of the equation. I'm going to do that on the right side as well. So I'm going to put 4 also here. So then we can go ahead and see that this one is a perfect square trinomial already. And we can go ahead and rewrite this as x. The trick is we take this number that we have right here, and this is what we pair up with x. So that's going to be x plus 2, and then square it. So if you use the area model, or if you multiply using the FOIL method, it's going to come out this, x squared plus 4x plus 4. And so we can go ahead and equal the other side as well. So this would come out 4y. We have negative 8 plus 4 is a negative 4. So I'm just going to go ahead and write that down here. So what we do next is we are going to factor this out. So this is how it's going to look like. So what I did was I factored out 4. And so if I use the distributive property, 4 times y is 4y. 4 times negative 1 is negative 4. This is already the vertex form or the graphing form of this general form of parabola. So I'm just going to go ahead and put that inside the box. Based on the review that we did at the beginning of this video, we can go ahead and say that this is an example of case 3, and we have a positive P. And so this tells us that this parabola opens upwards. So I'm going to go ahead and write that information up here. Okay, based on this equation, we can go ahead and say that the vertex of this parabola is located at negative 2, positive 1. And then this case again is case 3, and it opens up. Okay, to determine the focus or the location of the focus, what we do is we're going to use this number that we have right here. We remember that this part is equal to 4p. So I'm going to go ahead and write it down here. 4p is equal to 4. So whatever that coefficient coefficient of this quantity right here, that's actually equal to 4. So solving for p, we go ahead and divide both sides by 4. We can get p is equal to 1. So I'm just going to show the work down here. Okay, so we go ahead and sketch the graph of this parabola. We start by putting in the vertex. So the vertex is located at -2, 1, so that's going to be -2 and +1. So this will be our vertex. We remember that the focus is p distance from the vertex. So since we say that it opens up, so we go ahead and count one step up, because the p value is 1, and so we go ahead and say that this is where our focus is located. So I'm just going to go ahead and label that as F. And then we go ahead and say that the coordinate for the focus is -2, 2. I'm just going to go ahead and write that down here. Okay, now we remember that one end of the latus rectum has a distance of 2p from the focus. So I'm going to go ahead and write that information up here. Since we say that it's 2p distance from the focus, our p is 1. So we go ahead and plug it in. So that would be 2 times 1 would be 2. So we are going to count 2 to the left and 2 to the right from the focus. And that is where the ends of the latus rectum are located. So that would be 1, 2. So this is where the first latus rectum is located. And we count 2 to the right as well. So that would be 1 and 2. So this is the other end of the latus rectum. So that we can go ahead and sketch the graph. So this is the graph of this equation that we have up here. Now we remember that the length of the latus rectum is 4p, so that I can go ahead and write that length of the latus rectum. That means the length from one end of the latus rectum to the other end of the latus rectum. You can just go ahead and count it, but the formula to determine that is 4p. So I'm going to go ahead and write 4p here. So that means since we have p is 1, so 4 times 1 then is 4. So the length of the latus rectum is 4. And then we also have a line of symmetry. The line of symmetry is the line that crosses through the focus and the vertex. So we can go ahead and say that our line of symmetry is right here. Okay, the equation of the line of symmetry is x equals -2. Now let's determine the equation of the directrix. Now we remember that the directrix is located p distance from the vertex opposite to the focus, so that we can go ahead and say that our directrix is located here. Again, notice that the distance from the vertex to the directrix is equal to the distance from the vertex to the focus. And so this is the graph of this given equation that we have up there. Now let's move on to the next example. So in this example, we're supposed to write the vertex form and we're supposed to sketch the graph of this given parabola. The first step that I would do is to rewrite this equation. So what I would do next is to group together all the y's, and then I am going to isolate the 8x plus 25 to the other side of the equation. So I'm just going to go ahead and show the work right here. Okay, so what I would do is I am going to make this left side of the equation into a perfect square trinomial by completing the square. So I'm just going to go ahead and show the work down here. Okay, so what happened here was that, again, in order to make this into a perfect square trinomial, I'm going to divide the middle term by 2. It's going to be 2 every time, no matter what. And so negative 6 divided by 2 is negative 3, and then we are going to square it. So negative 3 squared would be a positive 9. And so I add positive 9 to both sides of the equation to make them even. And so we go ahead and tell that from here, we can tell that this is a perfect square trinomial. The easiest way to do that is just to get that binomial is just to whatever is when you divided it by 2, whatever the value for that would be the number that you put into the first term that we have here, and that is squared. And then what I did here was I wrote the negative 6x, and then I added the negative 25 plus 9 that came out negative 16. And then from here I'm gonna go isolate negative 8 here, and so the equation would look like this. Okay, so look at this very carefully. So if you notice, if we do the distributive property on this negative 8 times x would be negative 8x, and then negative 8 plus 2 is negative 16. And so that's how I got this value inside the parentheses. So looking at this equation that we have right here, we can tell that this p value is negative. And this is an example of case number 2 where the parabola opens to the left. So I'm going to go ahead and write that information right here. Looking at this equation that we have here, we can tell that our vertex is on negative 2 and then positive 3. And again, this case is case number 2 where it opens to the left. Okay, to determine the location of the focus, we are going to remember that this coefficient that we have here is always equal to 4p. So 4p is equal to 8. So that's negative 8. So 4p is equal to negative 8. So then doing the math here, to solve for p, we divide both sides by 4, divide this by 4. This tells us that our p is negative 2. So this is our value for p. So then we go ahead and sketch the graph here. We start with a vertex negative 2 and positive 3. So that is a negative 2, positive 3. So it goes up here. So this is our vertex. Now we remember that the focus is located p distance from the vertex. Since we say that this opens left, we go ahead and say that the focus is located to the left of the vertex, 2 distance or 2 units from the vertex. So I'm going to go ahead and count 2 units here. 1 and 2. So this is where our focus is located. So I'm just going to go ahead and label this as F for focus. And the coordinate for the focus is negative 4, 3. So I'm going to write it down here. Now, we also remember that one end of the latus rectum is a distance of 2p from the focus. So I'm just going to go ahead and write that information up here. Okay, since we say that the distance of the one end of the latus rectum has a distance of 2p from the focus, so what I did was I multiplied 2 times 2 is 4. So that means I go up 4 and down 4 from the focus, and that is where the ends of the latus rectum are located. So this is the graph of this equation that we have right there. Now we remember that the length of the latus rectum is 4p, so that's actually this number right here. So that is 4p is equal to 4 times negative 2 or 2. That's the distance. Since distance is it doesn't take any positive or negative value, so that is equal to 8. So that is the distance from one end of the latus rectum to the other end of the latus rectum. We can count it actually. That's 1, 2, 3, 4. 5, 6, 7, 8. That's the length of the latus rectum. Now we remember that our line of symmetry is located. It's a line that connects the focus and the vertex. So I'm just gonna go ahead and draw that line of symmetry right here. Okay, now we remember that the directrix is a line that is located p distance across the focus. So if from the vertex to the focus, that's the same distance from the vertex to the directrix. Since we say that our P is 2, so I'm just gonna go ahead and count 2 spaces to the left or to the right of the vertex, and that is where the directrix is located. So that would be 1, 2. So this is where the directrix is located. So this is the graph of this equation that we have up there. Now let's move on to the next example. So in this example, we're supposed to write the vertex form and we're supposed to sketch the graph of this given equation that we have right here. So I'm just going to go ahead and rewrite this equation. So what I would do next is I'm going to change this left side of the equation into a perfect square trinomial by completing the square. So this is the equation for this general form that we have right there. And we remember that this the p here is positive. Since the coefficient is positive 5, so it's positive. And this is an example of case 1. This tells us that this opens to the right. So I'm just going to go ahead and write that information up here. Now looking at this, our vertex is on -2 and 3. And then again, this is case 1 that opens right. So what I would do is I'm going to determine the focus or the location of the focus by equating this equation for P and solving for P. So I'm going to go ahead and show the work down here. Okay, so I solved for P. P is actually 5/4, and that is 1.25. So what I would do is I'm going to sketch the vertex on -2, +3. So that's located up here, 1, 2, and then +3, it goes up here. So this is our vertex. And we remember that the focus is P distance from the vertex. Since this opens to the right, the focus will be located to the right of the vertex. So that is 1.25 units. So that would be 1, and then 0.25 should be located somewhere around here. So this is where our focus is located. Now, we remember that the easiest way to write the coordinate of the focus is using this notation that we have here. That is H plus P, comma, K. So in our in this example, our H is -2. So I'm just going to go ahead and write -2. And then that's plus the P value, which is 5/4, 5/4, and that is comma, the K value is 3. So this is the coordinate of the focus. So we can go ahead and determine the location of the or the location of the two ends of the latus rectum. Now we remember that one end of the latus rectum is located 2p distance from the focus. I'm going to go ahead and write that information up here. So this tells us that one end of the latus rectum is located 2.5 up or on top of the focus, and then 2.5 down from the focus. So I'm gonna go ahead and plot that up here. So it says that it's gonna be 2.5. So I go 1, 2, 2.5 should be halfway between 5 and 6. So this is where the first end of the latus rectum is located. So we have 1, 2, and then halfway. So this is the other end of the latus rectum. So I'm just gonna go ahead and sketch the parabola. Okay, now we remember that the length of the latus rectum is 4p, and so I can go ahead and say that is 4p. And we remember that our 4p is just this one, whatever this number right here, that's actually the length of the latus rectum, so that is 5. Now we remember that the line of symmetry is located it's a line that connects the vertex and the focus. So I'm just gonna go ahead and draw the line of symmetry right here. So the line of symmetry is located y is equal to 3. Now we remember that the directrix is a line that is located across the focus from the vertex. So if this, and the distance of the directrix is 2p from the vertex opposite to the focus. So in this case right here, since our focus is located to the right of the vertex, our directrix then is located to the left of the vertex with a distance of P. So I'm just gonna go ahead and sketch that down here. So again, this is for the focus. That's the formula for the focus. Now the equation for the directrix, in cases like it doesn't come out like a whole number, the general equation for the directrix is x equals h minus p. So I'm just gonna go ahead and write that right here. So x is equal to h minus p. So this is the general equation of the directrix. So when we plug in the values here, that is, we plug in the value of h and the value of p. This comes out x is equal to our h is -2, and then our p is 5 over 4, so minus 5 over 4. We can go ahead and say that the equation for the directrix then is x is equal to 13 over 4. So this is the equation of the directrix. That's it. If you find this video helpful, consider subscribing and hitting the like button for more math videos. See ya!